Now you have seen the part where we build a model with using all the pre-processed datasets. And now I will guide you through the most efficient workflow, how to pre-process these datasets for your MikeG model in QGIS. So I leave the presentation. I start a new QGIS session here. I installed the latest long-term release 3.44 and all the data you will need in order to build this workflow you will find in this folder, which we will also provide you. Now, step number 1 is to store a new project, a new clean project in your folder. Now, under Preprocessing GIS, I call it now test 3. And it's always easier in terms to have the correct coordinate system orientation to directly load in a layer that has the correct coordinate system that you want to work in. Now in this case, I include here the rivers. All the data folders are categorized by module, and within there you normally find 1 to 3 folders. This is now not the best example. A good example is land use. You always find source data, tools if you need them, if they are available, and what you want to then produce at the end for MikeG, like in this case, the DFS2 raster files. All the steps that we will go now together through, you find in this new online manual. So everything that is relevant for recharge modeling, you find under applications and recharge modeling. And when you want to here define the model domain and configure it, you will find here links to the according sections within project from A to Z. So it will guide you completely through the model domain delineation, through all the pre-processing time steps. And you have a step-by-step guide for each single step, what to do in QGIS or in the MikeG toolbox. Now, in this case, I have already included the rivers. Let's check the coordinate system, which is in this case the UTM zone 32N for this northern Germany project. I normally always include a WMS background layer, or what in this case I take the top plus, which is quite nice and quite fast, and it shows a lot of details. Let's pull the rivers apart atop. We change the symbology to dark blue, maybe increase a little bit the thickness. Now the first step is to derive a meaningful model domain. In order to do that, what I normally do is if you are building such a model or try to get a first feeling of your catchment because you're applying for a public tender or you have a research project, you normally don't have a model domain. You only know where you are and where your focus area is. In this case, I know we are south of Borken here. This is my focus area here, this small river catchment. So the first step could be to create a new layer, a new shapefile layer. Step number 1, really ensure that also your project has the correct coordinate system defined. In this case, I take this one. Okay, apply. Working in the correct coordinate system is really essential for the whole pre-processing and for every modeling process and project. Now this is fine. Now we can create a new shapefile. I store this now under model domain, outputs for MikeG focus area. I call it focus area now in this case. I have already other examples. Geometry type polygon. And that's basically it. I click OK. Now I have a new area. I can toggle editing. This must not be precise. It's really more for your orientation before you derive the model domain, to say this is my focus area, and to have something for orientation. Then, in order to derive a meaningful model domain, this goes now by a little bit beyond the recharge modeling, I would always recommend to use a large DEM. It can be coarse. Then if it's a different projection, you need to define here a good projection with a low accuracy, high accuracy. Then we have already a topography, and it can be helpful to include not only the rivers, but if available, also the surface water catchment, which is here stored under overland floor, surface water catchments. I give the DM a little bit of transparency. Maybe a better coloring palette. This is what I was searching for. Not random colors. Maybe this one. Okay. To get a better impression of the topography. Okay. Then you basically have already everything to delineate a surface water catchment, of course. But since we want to build a groundwater model, it can be recommended to also include groundwater isolines if available, or you can construct them yourself to get a better understanding here of the groundwater flow. Now the first step is to create a new model domain, create layer. We did that already. We store it under model domain, give it a new date. Of course, it should also become a polygon. Choose the correct coordinate system again. Okay. And again, we can now toggle editing here and start drawing a polygon. Now in this case, I know for sure I want to include this surface water catchment, but it can be that there's also some interaction here with this groundwater parts, and for sure, obviously, this neighboring catchment is also kind of flowing into my very close to my focus area. So I search here for a nice groundwater separation line, and I can now start here. Here I follow the surface water catchment, which perfectly aligns with the separation line of groundwater isolines. Here, obviously, these catchments are flowing outwards, not towards my focus area. So I can go here between these two, follow here again then my surface water catchment a little bit. And then obviously here is a higher area. Also, these catchments are not of interest for this zone here. And I can go now here downwards. And then consider for my groundwater model this bigger river as boundary. Now I have here my model domain. I save the layer edits, turn off the editing mode. Now in order to create a meaningful preprocessing mask, you can search here for extract layer extent as a function. I take the model domain with the correct coordinate system, And now you should round the values to a value that represents the coarsest model resolution you want to use further. The rest will be part of the MikeShe workflow. During the preprocessing, a resampling will be done, but it's always recommended to choose a value of at least 1000, maybe 5000. You can also create a temporary layer if you want, and you do not need to save every single step. Now in this case, I do a temporary layer for the moment, and then later export it. Which will then be the template in order to create all the other data sets. I remove this layer, I don't need it anymore. Focus area, I can turn off the toggle, the editing also. I don't need it for the moment. Surface water catchments I can now turn off also. So for this model domain, we will preprocess now the data. You could also change here with the vertex tool manually by clicking one time on the vertex and extend here the model domain if you want. If you want to ensure, then if you right click here on one of the vertices, you can ensure this numbering. So you can really manually here round the numbers again. Here I think we can directly go for the 800 and 800. It's always useful if you have a very perfect rectangular mask. So we do that now. Then we can save it, unturn the editing mode. And then we have our preprocessing mask. With that, we can now start converting our rasters into DFS2 or ASCII file sets. So the workflow is always to produce ASCII raster datasets here in QGIS. And with the Mike0 toolbox, you then can convert them into DFS2 rasters. Now, for converting the raster datasets like the DEM, you can use the warp function. I take here my DEM. Source coordinate system is clear. It can read it out of the DEM, but I want to have it in UTM. For elevation data, you always should take the bilinear data, and the extent should be our data collection mask. So we want to save this to a file. Now DEM50. You can give it also the coordinate system name. Now version 3 in this case. And important, since we do here also a resampling, so we do a reprojection, we do a clipping, and you can also give it output file resolution. Now in this case, I choose here the 50. I click run. That looks good. I turn off the original DEM, and I have now, if I put here the data collection mask above, you see it's perfectly matching. Double check again if the coordinate system is correct. It is. The model resolution is now 50 and 50. That's fine. And we have rounded corners of our extent. So the DEM is ready. And I think it's actually already an ASCII file. Yeah, that's good. ASCII, so we can directly reuse this later. Then we directly come to here the land use. DEM is ready. Climate will be an Excel workflow, which I will show later. And we take here, in this case, the coordinate dataset, which is a land use dataset that covers whole Europe. And the raw dataset, as most of the global datasets that you will use, they have a kind of code. And what we did for our projects here in Europe or Germany, and you can do this also for your projects. If you go to tools, you find here a land use MikeShe lookup table. And here we linked every Carina land use grid code to the Carina land use. And these we categorized into our standardized land uses that we are normally using in MikeShe. Because then we can easily convert these into our grid codes, combine them with our ETV file that you have already seen in the previous part of this live demo, and directly derive Manning values and subsurface leakage coefficients depending on the land use. You see here a building which has no transpiration, has no LRE and no root depth, a Manning of around about 30, and certain leakage. Residential area which is supposed to have more grasslands has a slightly lower or slightly higher subsurface leakage. And streets are nearly completely sealed with 1E-7. So this is the unit 1 per second. So we have now our land use grid code. We can now clip this one. It's a vector data. So we clip our land use here by our data collection mask. Actually, this time we really create only a temporary layer. That looks good. So it's clipped. I turn that one off. And now I make here a join. If I go here to properties, I can create a new join. Sorry, I need to first load in the lookup table here into QGIS so that it's able to be picked up. Now I take my clipped layer, right click properties, create a new join. And I want to join this land use map. The join field in my shapefile is, in the lookup table is this CLC 18 file. And the target field is the CLC in the shapefile. Okay. Apply. I can even, I think, in the join, check if it worked. Yeah. If I right click now and look into the attribute table, I can see that here the category was attached. Also the building, the category, my MikeShe categorization, the grid code, the ETV file type, the Manning number, and the subsurface leakage coefficient. Now I'll save this as a separate layer. This is now the clipped one. It's now version 3. I give it another projection. Extend is already clipped. Okay. I can turn that one off. Just ensure that the fields are still there. Now I remember the grid code is field 2. Manning is 4. Subsurface leakage coefficient is 5. And now I can create directly 3 rasters based on this input. I take now field 2, output raster size units, and then we again take here the 50 as cell resolution and save this to a file. I do this now under land use here. That's now the land use grid code 3. I click run. Sorry, I need to give it here the correct unit. It's georeferenced units. Okay. Now we had one problem. The output file. That's a good thing. It does not close. You can change it here. It's not allowed to directly convert it to a ASCII raster. I first need to convert it into a TIFF file. Now it's working. Very good. Then we do the same for the Manning, which is field number 4. I simply change here the name. And run it. Manning raster created. And we do that also for the subsurface leakage coefficient field. Okay. Now we have the DM and the land use, the Manning, and the subsurface leakage coefficient fields being created. You also need the translate function, is it called, where you can take now here, where is it here? Our TIFF file that we just created and convert it into a ASCII file. I do it now only for the land use grid. Okay, now we have it here in ASCII. From time to time, you should always check if the model resolution is still the same and the extent was maintained. No, this was not the case. Let's check again if the original grid still has the correct. No. So during the rasterize, okay. I will not redo all the steps, but just to show what I missed. In the rasterize, you should consider here also the output extent. Calculate from layer, and again do the collection mask. I think it's too small. Okay, that should be fine. Now we have done the land use. The only missing bit is the soil map. So we go here to the unsaturated zone and take here the raw data, which is the BK50. Now, this is maybe a little bit the challenge for every area. You need to create the first time here the corresponding values. You can try to figure out, this is now a German soil map based on the values and based on the classification that you can recognize here in your soil map. If you can match it with the USDA soil classification, that would be the easiest one. Then you can convert this or use this as shapefile or as raster file also in MikeShe to assign the grid codes. Or here you can see, in this case, the German classification. If you want to go for the Richards approach, then you can take here only the classification like sandy loam, sand, and then assign it with the corresponding UZS file I just showed in the previous live demo. If you want to go for the 2-layer method, you need to figure out how to derive the values directly in order to be able to use this HTML importer file. So in this case, the saturated water content, field capacity, and so on. In order to assign these fields, I will not go through these steps myself. I will instead route you to the really very detailed unsaturated zone description part of the preprocessing. And you will see here also the steps how to try to, if you go here to the BK50 shapefile and load that, you see actually all the steps that we did, clip it and process it. And here you can create also new fields, how to create a new field example for the water content and saturation, how to join these fields. And then you will end up with this polygon shapefile we used in the previous part of this live demo, how to include this here directly with the DBF file and import the values with the HTML file. Now we are done with nearly done with the post-processing. The only thing that is missing in our MikeG model now would be the grid in order to produce to assign the groundwater heads. Now only for the recharge only applications where the saturated zone module is deactivated, you find here also a workflow under preprocessing saturated zone, how you can interpolate groundwater isolines or construct them yourself or even correct them for mean values that are measured on point data, and how to create again such a grid that we used in the MikeG manual. Now we are already done with the QGIS preprocessing in less than half an hour. The last missing thing is to create the precipitation and evapotranspiration inputs. Now I assume that you at least get somewhere daily or even hourly values. And if you have a single time series here with a date and a value, it could look like the same for the evapotranspiration. We normally use here the Penman-Monteith, which is the recommended and globally agreed method to do that. You have here the daily values. Now in this case, here the Penman-Monteith. But we do this example now only for the precipitation. Again, you can create a new DFS0 here directly from scratch. New file, Mike0 time series. And we say it's a blank time series. Precipitation, we can give it an equidistant calendar axis. I make it now here PP, give it directly the correct item. Precipitation rate, millimeter per day. We make it step accumulated, mean step accumulated. For daily values, for hourly values, I recommend you to use instantaneous. And then we say with daily values, here our time step is daily, 1 day. Then we check here the start datum, which is the 1st of January. (1941). Then we check the number of time steps, 29 to 18. Click OK. Now we get a blank time series here with the precipitation. Oops, it's too small. Oh, I made a mistake here, but that's not a problem. I can change that. 1941. You can also give it here the item type of non-equidistant, so you don't need to provide a value for each date. And then you can simply copy paste with Control-C and Control-V here the values. Now in this case, you see we have here outliers, which is quite a common problem. You can left double click here in this area and you will see here our wrong values. And we normally assume here a 0. Then you can save them under preprocessing climate PP outputs for mic as precipitation. The same you do for the ET. Now the outlier is not visible anymore. And your precipitation time series is ready for mic Xi. So this is the complete workflow. Now you have everything you need. You have a DEM, topography, the land use, you have the soil map for Richards or 2-layer, and then you simply need to click together the model like we did it together in the previous session. Now we are at the end of this webinar. Turning back to the presentation for one moment. Maybe worth mentioning again that there is a free of charge webinar available on demand. You can register and directly watch how to evaluate these water balances, like I showed you also at the end of the mic sheet demonstration. We also have auto calibration tools that can be used also for recharge calculations, which is automatically shipped to you and available if you have purchased a mic sheet license. You also do this in mic 0 with a new file under mic 0, and it's an auto calibration file. We will pretty soon publish a video and a tutorial how to use that. And there is also a Python-based auto calibration library available. It was developed by Copenhagen University and GEOS in Denmark. We are currently looking into that and trying to improve it a little bit for mic Xi users. And you will find news on that also pretty soon in our model demonstration. So we are done for today. Thank you very much for joining. Again, worth mentioning, really, if you get stuck, just look into the new online manual. You find here a lot of good guidance. And if you have a project and you want to discuss the requirements, or you really get stuck and don't find what you need, don't hesitate, just write me an email, phhu@dhigroup.com. I'm really looking forward to help you to learn mic Xi if you want and apply it in your projects to improve the confidence and reduce further the uncertainty in your groundwater models like MODFLOW or FEFLOW if you want to use mic Xi as a recharge modeling tool in order to derive better estimations for possible new available groundwater abstraction permits. That's it from my side. Thank you very much. Have a nice rest of the day, and I'm looking forward to stay in touch with you all.